Hello, hello, hello. Welcome to week 5 of Math with Matt. This is the last week of similarities. I hope you like this sweet, sweet graphs I've got flowing just for you. This final roundup of similarities is mostly videos that I want you to watch, and you don't even have to completely understand what happens in all of them. I just want you to gain a little bit of appreciation for the applications of similar triangles. But let's first go over some intro videos. So the first video I want you to watch is called Using Similar and Congruent Triangles. And this is a big old problem where you got a triangle and you're trying to figure out what the area of this little steeple looking thing is. First things first, you got to remember that the area of a triangle is half of the base, which is this long thing down here, times its height. And the height is not a hypotenuse or any sort of side that's at an angle, it's straight up from the base. I guess they're all from the base, but so we already have that height, it's 24. The only thing is we need this length. Well, actually, do we even need that length? I think we do. But look, they found 12 and 6, so we know that side is... There's a whole bunch of information that you know because of the video, but the idea is that you have to use similar triangles here, this triangle, and then this bigger triangle. You're going to have to do the same for over here. That triangle and this big triangle. And again, with similar triangles, it's all about ratios. So for the small triangle, I could do 8 over 6 is the same thing as 24 over, not 12. 12 is just this little chunk. It'd be 24 over 18. Whoa, can't see that, can you? Ding dong. Alright, so while that would look, I'd do 8 over 6 is the same as 24 over 18. That's our ratio. Well, actually, we'd probably have like a missing, probably have like an X here in the video. But that's the type of thing that you'll need to be able to do. The video is helpful in that, I'd say, but let's keep going. All right, here's another one. The tricky thing is here is you have to remember that the angles are the ones that are the same. So see how I've got this small triangle with a 90-degree angle right here and that dinky little sucker angle right there? Well, if I look at the big triangle, I got a 90-degree angle. Oh, and that same dinker right there. So I don't even have to know what this angle and this angle is. I just automatically know that they're going to be congruent, and all 3 angles are congruent. Then you got similar triangles. So what they eventually start doing is they want you to find, I don't even remember what they want you to find. They want you to know that like this and this, you just add some variables to find CF. So in this case, they do CF is to X as 9 is to X plus Y. And then they do the same thing on the other side. It gets a little tricky when you have to they factor out I think it's a Y, and it creates a little messier of a little thingamabob. But if you have questions about that, I'm gonna help you with that. Just hit me with your best shot. All right, but here's the actual good stuff. All right, so here are some actual problems from the practice. So find the perimeter of ABC. Perimeter means the distance if I walked all the way around a place, how far did I walk? Well, right here I got 18. Right here I got 10, but what is P to B, huh? That's my missing thing. Then I go 7 and then 14. So I can just do this already, this part of it. 10 plus 18 is 28. Plus 7 is 35. Plus 14 is 49. Look at that. All right, so I basically have to find out what's 49 plus x. So what the heck is x? Guess what we're going to use? Similar triangles. So I'm going to use this side, and this is my x. Now, how do I know that these are similar triangles? Well, here, the small triangle has this corner pocket, right? And so does the bigger triangle that encases it. So that angle is congruent in both of them. And then, because I know that these are parallel angles, I know that they share congruent angles based on this transversal that hits both of the parallel lines. You can, I mean, it's something we looked at last week, but if you can see it, it just makes a lot of sense. So let's make our first ratio. 7 is to x as this long side a to b, so that's 21, is to, now this is where it gets a little tricky, 10 plus x, right? Because c to b is c to p, which is 10, plus x, so 10 plus x. Then we do some cross multiplying, my favorite thing. Can you see that? 21x multiplying here. I'll show what I'm doing. I'm multiplying these two things, and multiplying these two things. So 21x equals, now 7 times 10 plus x is 7 times 10, 70, and then 7 times x, which is 7x. I'm going to move this 7x over. What's 21 minus 7? 1s and 7s are not my friend, but I know it's 14. So 14x equals 70. Anybody got to guess what x is equal to? Well, just divide both sides by 14. But if you do it, you probably figured it out, that x equals 5. But the answer, my friends, is not just 5. It's 49 plus 5, so I'm looking for that perimeter. So the answer is, well, that's backwards 5. 54 units, whatever that happens to be. Okay, this one I actually found to be easier, but I'm looking for the area of D, oops, DUO. So here's that triangle. Now, to find the area, you got 1/2 times base times height. Now it's upside down, but even though it doesn't look like the bottom, here's the base. It's basically a flat land. So I got, let's change colors. Give me a different color. 14. 1/2 times 14 times the height. So this is the height, m to u. I don't know what that is yet, so I'm just going to call it x. Okie dokie. Now, let's look at this little triangle, MUD. We know that this ray, RD, is perpendicular, so it makes two right angles. And we know that this UDR is the same angle as RDA, just by those two lines. So that means that the leftover angles, because they both are complementary or add up to 90, have to be the same. So that means MUD is congruent to PAD, or not congruent, similar. So we can do our lovely ratios. Only thing you got to do is make sure you got the sides right. So 4.5 over 3.75. So I'm showing you that this and this side, a long side and a shorter side that make up the 90-degree angle, are the same as this side and this side. Now, it's maybe hard for you to tell, but this MU is a corresponding side to PA. So it's important that you put mu at the same place as the PA, so that means the top of the fraction. So and then MD is 10, so 4.5 times 10 is 45 equals 3.75. Ooh, that is some ugly. 3.75x, right? So then divide both sides by 3.75. Man, wish I had a pen. So what's 45 divided by 3.75? Whatever that number is, I plug it in here. Let's do it. I'm just going to show you how to do it. I'm just going to show you. Okay, so here's my calculator. I do 45 divided by 3.75. Hit enter. 12. So I'll put a 12 right here. I got half of 14 times 12. What's half of 14? 7. So what's 7 times 12? Well, 7 times 2 is 14. So I carry the 1, so that should be 84. Alright, last one. Find the length of HD. This is a trick question. They're trying to trick you. So again, similar triangles. We're going to find the HP. Well, let's make it an X. It marks the spot. Again, using our similar triangle ratios. But what is eventually going to happen is we're going to find X plus 9. Because it's this whole distance. X plus 9 equals this whole distance. Alright, so let's make our ratio. 6 long side over X short side equals 9 or 27. 9 or 27. 27, because that's the long side over the short side. Now, what's 9 times 6? Cross multiply. Of cross multiply. Crossing the corners. Don't you know where I've been? 54 equals 27x. Divide both sides by 27. Don't you know where I've divided? Don't you know where I've been? So 54 divided by 27, what's that equal? Well, happens to equal 2. So our answer is 2 plus 9 equals 11 units. Oh my gosh. Those are 3 problems worked out to completion. You're welcome. Alright, so the next video is diving into the golden ratio, which is a really cool number that people have used. Phi, that's this Greek symbol, and that's a bad version of it, but so phi shows up in all sorts of stuff, like even in the shape of roses, this golden ratio, and this Dutch dude named Rembrandt used to paint according to the golden ratio, and that's basically what this video is showing you, is that even in art, which sometimes follows nature, which seems to somehow follow math, or we figured out a math that it follows. And so it's all pretty wild, maybe a little conspiracy theory-ish, but mathematical nonetheless. And so they go so far as to talk about the distance between the Earth and the Moon and comparing the radii. So that's just plural for radiuses. Remember, that's the midpoint. Maybe you don't remember, but maybe this is new. Point in the middle of the circle out to the edge. And they seem to have placed the Moon on top of the Earth. And I feel like I was reading something. I was reading a poem the other day. I think it was called 8 Moons. My person and I were reading poetry, and the poem was called 8 Moons. And I guess the Earth could fit 8 moons in its ocean. Isn't that weird? I think that's weird. Anyway, so is it cool? Up to you. But that video is all about the golden ratio and the Earth and the Moon. But let's get serious. The real reason we're here is so that we can win at 8-ball. So when you use what they call off-the-wall shots, Vans, peace be with you. When you do off-the-wall shots, that's not the real name, but there's actual geometry that you could be using to see exactly where you think that's going to hit. So if I want this, I've been doing these shots to break off the wall so that it bounces and hits back here. And it's all about similar triangles. I could make a similar triangle here to find out where it's going to hit here, and then from where it hits here, I can find out where it's going to hit there. It's so cool. Anyway, watch the video. It looks really great. I hope you're doing well. Take the unit quiz. Take that quiz 2, or take the quiz 2, and then take the unit test. See how you're doing. We're going to move on from here after that, but I hope you're doing well. And yeah, see you later. See you later. Uh-oh, how do I turn this off? Uh-oh.